electron volt forbidden gap. That means it is not easier to electron passes through this forbidden gap and reach to conduction band. So electron cannot go easily, but if temperature is very high, then and then few electrons can go from valence band to conduction band. So it's called very small electric current, or maybe a few leakage current may be passed through the insulator, and due to this temperature, due to this effect, the temperature coefficient of insulating material is negative. Insulating material temperature coefficient is negative. Same condition we go for the semiconductor material, conduction band, forbidden gap and valence band. But here forbidden gap is very small. With increase in temperature, electron can go from valence band to the conduction band, hence it increases the conductivity. Now here conductivity is increased when the temperature is increased, because at the increase of the temperature some electron get energy, and due to the energy they easily cross the forbidden gap and go into the conduction band. So semiconductor is provide sometime conductivity at the high temperature, but not a more number of electron passes from valence band to the conduction band. Hence the temperature coefficient of the semiconductor material is also negative. And conductor, in conductor there is conduction band and valence bands are totally overlap. So in conductor there is a due to large number of free electron, as the temperature is increased, the conductivity is also increased, because electron can easily go from valence band to conduction band. There is no any barrier, there is no any forbidden gap, so electron easily pass from the valence band to conduction band. Hence we can say that the temperature coefficient of conductor material is positive. So remember, in insulator and semiconductor temperature coefficient is negative, while in conducting material temperature coefficient is positive. So in 3 marks it is a very short and simple question. Now good example, an iron ring has a cross section of 400 mm square and mean diameter of 25 cm, is bound with 500 tons. If the value of relative permeability is 250, find the total flux is set up in the ring, the coil resistance is 480 ohm and supply voltage is 240 volt. There is so many data is given, but we have to find out only the one thing is total flux set up in the ring. Which parameters is given? Iron ring cross sectional area, iron rings mean diameter and number of turns wound on the iron ring. If permeability is also given 250, the coil resistance is 480 and voltage given to the coil is 240 volt. We have to find out the total flux set up into the coil. So let's do with the given data. We go with the example. See here, area is given, area of the ring is A equal to 400 millimeter square. We always remember one thing, that data is given in the appropriate form or not. Here data is given in the millimeter, so we have to convert it into the meter. So 400 into 10 raised to minus 3 square meter square, so it is 400 into 10 raised to minus 6 meter square. Now next thing is mean diameter. Mean diameter is 25 centimeter. As we know that diameter always mention into the meter, so 25 centimeter is equivalent 0.25 meter. 0.25 meter. It is mean diameter. So what will be the total length of our iron ring? See, question understand it is a one iron ring. Here number of turns wound, here voltage is apply, here mean length is given. So total length of the ring is given by pi into dm. So pi into dm 0.25, multiplication of pi and 0.25 we get 0.785 meter. So mean length is 0.785 meter. And another data is given, n equal to 500 number of tons, relative permeability is 250, resistance is 480 ohm, and voltage is 240 volt. We just need to find out total establishment of flux, how much flux is established into the ring from the given data. So now we know the one formula, it is reluctance is equal to, we know the formula, flux equal to mmf upon reluctance, mmf upon reluctance. So we have to find out the formula of mmf and reluctance. So first we have to find out value of mmf, then we find out the value of reluctance, then we can find out the equation of or value of flux. So first go with the mmf. So here current flowing through the circuit is given by I equal to V upon R. So applied voltage is 240 volt, resistance is 480, cancel out 0 and 0, 24 2s are, that means 1 by 2. So current is 0.5 ampere. Now we go for mmf. mmf is given by n into I. Establishment of current is 0.5 ampere into number of turn is 500 into 0.5, that means it is divided by 2. So simple, I get my mmf is 250 ampere into turn. Value of mmf is 250 ampere into turn. We have write down I ampere into turn, one number which is the value of mmf. Now I find out the value of reluctance. So let's go with the reluctance. Reluctance S equal to L mu 0 mu r A. So put the value. L is the length of ring, which is 0.785. Mu 0 is a standard constant and its value is 4 pi into 10 raised to minus 7. Relative permeability in data given 250 into 400 into 10 raised to minus 6. Now after solving this term, we get 624 into 10 raised to 4 ampere turn per Weber. So value of reluctance is 624 into 10 raised to 4 ampere turn per Weber. Second value. Now put this two value and we get value of flux. So flux is given by is given by mmf upon reluctance. As we know that value of mmf is 250 and value of reluctance is 624 into 10 raised to 4. Solve this term, we get, see, 250 upon 624. 10 raised to 4 go in numerator, it becomes 10 raised to minus 4. Solution of this term gives 0.400 into 10 raised to minus 4. Now we want to get the value of flux in standard term, then we go with 0.04 into 10 raised to minus 3. Then value of flux is 0.04 milliweber. 10 raised to minus 3 converted into the Weber. So 0.04 into 10 raised to minus 3 Weber. So value of flux established or flux set up into the ring is 0.04 milliweber. So complete sum for the 4 marks. So first we have to find out the value of mmf, then we have to find out the value of flux, and then we can get the value of set up flux. So for a 5 mark, it's easy to calculate. Now next is OR. In OR, the question is that explain in a detail RLC series resonance. Question for a 5 marks. Now earlier we have discussed RLC impedance. Now we discuss about the RLC series resonance. See, this is the series resonance circuit. Here voltage is applied Vs or Vm sin omega t. Current flowing through the resistor, inductor and capacitor. Voltage drop of resistor is Vr, inductor is Vl, and voltage drop of capacitor is Vc. Now we have to discuss what is the resonance, or when resonance is occurs in series RLC circuit. So in this circuit we first go with the each and every value. Now see, it is frequency dependent component, where R is not a frequency dependent component, but inductor and capacitor, these two are frequency dependent component. So when we apply the AC voltage with a variable frequency, the impedance of XL and XC is change. Okay, so let's see the value of inductive reactance. Value of inductive reactance XL is 2 pi FL, and value of capacitive reactance is 1 upon 2 pi FC. So here XL is directly proportional to frequency and XC is inversely proportional to frequency. And that term, if I increase frequency, then XL is also increases, but my XC is decreases. Capacitive reactance is decreases in series RLC circuit. So let's see in figure. We understand that it is a graphical relation between frequency and reactance. Inductive reactance, where inductive reactance XL is directly proportional to frequency. So as my frequency increase, inductive reactance is constantly increase with the linear slope. See in the figure, if my frequency is 0, then inductive reactance is 0. My frequency is 1, 2, 3, 4, then it is linearly increase as arrow is indicated. Now capacitive reactance, as the frequency is 1 upon F, so as my frequency is increases, capacitive reactance decreases. See the graph, so the frequency is decreasing towards the 0. If my frequency is 0, then capacitive reactance is high or infinite. If frequency is infinite, then it is a 0. So vertical graph is represented here. Now what is resonance or how series resonance is occurs. So in RLC circuit, when XL and XC becomes equal, see in series RLC circuit, when inductive reactance and capacitive reactance becomes equal, resonance is occurs. Resonance occurs means when XL become equal to XC, resonance is occurs. Now put the value of XL and XC, I get omega L equal to 1 upon omega C. Take omega on the front side, so it becomes omega square 1 upon L C. Now taking out square root on the both side, so 1 upon under root L C. Now put omega equal to 2 pi f, and as it is a resonance frequency, so we put 2 pi f r equal to 1 upon under root L C. Here 2 pi goes into denominator, so equation of resonance frequency is Fr equal to 1 upon 2 pi root L C. So series resonance is given by Fr equal to 1 upon 2 pi under root L C. And what is the exact definition of resonance? Say in series RLC circuit, when inductive reactance become equal to capacitive reactance is known as resonance. If we go for graphical relation, then when the graph of XL and XC is intersecting, then resonance is occurs.